Alright everybody, in this video I'm going to explain variables in the C programming language. You're probably used to variables back in middle school. A variable represents some value. Well, in programming we have something similar. A variable is a reusable container for a value. The variable behaves as if it were the value it contains. But we do have the capability of storing more than just numbers. There's different data types. Let's begin with the data type of int, meaning integer. To create an integer variable, we will say int, meaning integer, then we need a unique name for this variable. Let's say we're working with ages. Let's say int age. We'll assign this variable a value using equals. So let's say that I'm 25. In the C programming language, we have to end each statement with a semicolon. So we can use this variable age, and it will behave as if it was the number 25. To display this variable, we can use that within a print statement. So printf. In the C programming language, to display a variable, we'll have to use a format specifier. Let's say we have a string of text, such as you are our variable age, years old. To insert a variable, I'm going to use a %sign for a format specifier. To display an integer, we'll use d, meaning decimal. Years old. Following the string of text, I will add a comma, then the variable I would like to insert, my variable age. Let's give it a test run. You are my variable age, which is 25 years old. So an int is a whole number, a whole integer. If I were to say 25.5, like it's my half birthday, well, we end up truncating that decimal portion because integers can't store decimals. To store a whole number, you can use an integer. Let's create another variable. Repetition is going to help us remember these steps. Another example of an integer could be a year. Int year. What year is it? I will say 2025. Then I'll create another printf statement. Printf. Let's say the year is, wherever I would like to insert a variable, I will use a format specifier, that %sign, then use d for decimal. Comma, then my variable of year. The year is, and then let's be sure to add a new line character, because I forgot to add that. New line, new line. That's better. You are 25 years old. The year is 2025. Let's create another. What's another good example of an integer? Perhaps a quantity. Maybe I'm buying just one product. You wouldn't have, half a product, right? Quantities would be whole numbers, typically speaking. So let's say printf. You have ordered. We're inserting a variable. We'll need that format specifier. %d. You have ordered our variable X items. We will insert our variable of quantity. Let's give it a test run. Then a new line character. Okay, here's our variables. You are 25 years old. The year is 2025. You have ordered one X item, or items. And then we can change these values too. Maybe I would like to buy 2 items for the quantity. You have ordered 2 X items. Alright, so those are integers. They're just whole numbers. They don't have the capability of storing decimal portions. That's where the next data type is going to come in. To store a decimal portion, you can use a float, meaning floating point number. What's a good example of a number that contains a decimal? Perhaps a GPA, a grade point average. Float GPA. I will set this to 2.5. Hey, C's get degrees, right? Then to output this, I would use printf. Let's think of a sentence. Your GPA is, use a format specifier. Then for a floating point number, we're going to type f for floating point number. I'll add a new line character because I'm probably going to forget to do that later. And then I will display my variable of GPA. Your GPA is 2.5, and then a bunch of zeros after. C has a default behavior of displaying 6 digits after the decimal when working with floating point numbers. We do have the capability of changing that, but that's going to be a future video. You could add dot and then a number to display a given amount of digits after. Your GPA is 2.5, but that's a whole nother topic. We'll cover that in a future video. Another good example of a float could be a price. Float price equals 19.99, like $19.99. We will use printf. The price is, I'll pick a unit of currency. I'll pick American dollars, but pick whatever you would like. To insert a variable, we'll use that format specifier, the %, then F for a floating point number. Then I'll add a new line character because I'm probably going to forget if I don't. The price is, we will insert our price variable. Let's see what we have. We have our GPA, 2.5. The price is $19.99. To display 2 digits after the decimal, you can use 0.2. More on that in a future video. A temperature could be a floating point number. Float temperature negative 10.1. It's really cold outside. We'll use printf. Let's say the temperature is, add a placeholder, F for floating point number. Then I'll add a new line character. Then display our temperature variable. The temperature is negative 10.1. This can be Celsius or Fahrenheit. Let's add that in. To add a degree symbol on Windows, hold Alt, then type 0176. I'll say F for Fahrenheit. The temperature is negative 10.1 degrees Fahrenheit. Then you can set the precision if you would like, but we're not at that point yet. Alright, so those are floating point numbers. They're numbers, including a decimal portion. We only have the capability of storing 6 to 7 digits after the decimal. If you need more precision, such as if you're working with pi, you can use a different data type known as a double. So let's say double pi equals 3.14159. Then I don't know the rest, so I have to look them up. So with doubles, you can store 15 to 16 digits after the decimal. And then to display a double, we'll use printf. Let's just say the value of pi is, use a format specifier, then type LF, meaning long float. Then we will display our variable pi. Now again, the default behavior of C is to display 6 digits after the decimal. You'd have to use point, followed by the amount of digits you would want to display. Let's say 15. Another example could be E, Euler's number. This I gotta look up. I'll just copy this. The value of E is our variable E. Oh, then add a new line character. The value of pi is 3.14, and some change. The value of E is 2.7, and some change. If you have a decimal number that needs high precision, you can use a double. In this series, we'll probably not be working with doubles too often. We'll stick with floats. But at this level, you should still be aware of the existence of doubles. With variables, you can store more than just numbers, you can store characters. Another data type is char, meaning character. Let's say we have a letter grade, like what grade did you get on the exam? When working with characters, you need to use a set of single quotes. Let's say we got an A on the exam. That's our grade. Then to display this, let's use printf. Your grade is format specifier, then C, meaning character. Then I'll add a new line. Let's display our grade. Your grade is A, or if I failed, this could be an F. Your grade is F. Let's think of another example. Perhaps a symbol. Char symbol equals, then within quotes, pick a symbol. I will pick, let's say, exclamation point. That's the first thing that came to mind. Let's print our symbol. What can we say? I can't really think of anything, so let's say your favorite symbol is %C followed by our symbol. Your favorite symbol is an exclamation point. What about currency? Char currency equals, pick a unit of currency. I'll pick American dollars. Printf. The currency is %C to display a character. Then we will display our currency variable. The currency is dollars, American dollars. Alright, those are chars. They store a single character. If you've programmed in a different language before, you're probably familiar with strings. Well, in C, we don't have strings. In other languages, a string is a series of characters, such as a name. In the C programming language, we use an array of characters to represent a string. So, to store more than one character, we can use char again, because we're working with characters. Think of a variable name, such as name. Then add a set of straight brackets. This is an array. An array can store more than one value, so to say. We will set this equal to, then use a set of double quotes. So now we can store more than one character. Why don't you type in your name? I'll use my YouTube channel name. Alright, then to print our string, well, our array of characters, technically, we'll say hello, format specifier, then S, meaning string. New line. We will display our name. Hello, whatever your name is, whatever you typed here. With our array of characters, also known as a string in other languages, you can store more than one character. And again, they do have to be within double quotes. So what's another example of an array of characters? Perhaps a food. The name of a food. So char, food, straight brackets. Think of a food you like. I'll say pizza. Printf. Let's say your favorite food is, format specifier, S, because we're displaying a string, food. And I'm forgetting that new line. Hello, brocode. Your favorite food is pizza. What about an email? Char, email, straight brackets, equals, then within double quotes, I'm going to say fake. Now with strings, you can include numbers, but they're treated as characters rather than numeric values, so we can't use them with any sort of math in the future. We have a character representation of the numbers 1, 2, 3. Then I'll add an extension of @gmail.com. I don't want to give you guys my real email because some of you guys are weird. No offense. Your email is %S. I'll add a new line. Email. Hello, brocode. Your favorite food is pizza. Your email is fake123@gmail.com. One last data type we're going to cover is bool, meaning Boolean. Booleans are either true or false, but to work with Booleans, we have to include this header file. At the top, we'll include stdbool.h, meaning standard Boolean, and this is a header file. To create a Boolean variable, we'll type bool. Bools are binary. They're either true or false. True means 1, false means 0. There's only 2 possible values. This could be good if determining if somebody is online, for example. We'll create a variable of is online. They're either online or they're offline. So let's say that this is true. So true also corresponds to the number 1. That's also valid. Or if somebody was offline, this could be false. This also corresponds to the number 0. We tend to use Booleans more internally within a program, such as when working with if statements, but you should still be familiar with them at this level. If I was to display a Boolean variable, this is what it would look like. So I'm just going to use a format specifier, %d. We will display is online. This would give me the number 1. 1 also means true. If somebody were offline, let's set that to be false, this would be 0. With Booleans, we tend to not display them directly using print. You would more likely see them be used internally within a program, such as within an if statement. If statements are a future topic, but I just want to give you a quick demonstration. You would type if, a set of parentheses, a set of curly braces. If is online, if this value is true, or 1, or do something, such as you are online. Or we can do something else, using an else statement. Printf, you are offline. Let's give it a test run. Our Boolean of is online is true. Since this is true, we would print, you are online. The number 1 can also represent true. You are online. Or if this were false, well then we would execute this code. You are offline. False also corresponds with 0. You are offline. However, as humans, using true or false is more understandable to us. By looking at this code, we may not know what 1 means, but true or false makes more sense. Okay, let's do another example. Let's say, is student. I will set that to be true. If is student, if that's true, you are a student. Else, you are not a student. Maybe you're alumni. Forgetting that semicolon. You are a student. If this were false, then you're not a student. One last example. Bool for sale is something for sale. I'll set that to be false. If for sale, that item is for sale. Else, that item is not for sale. That item is not for sale. If it were true, then the item is for sale. So Booleans are either true or false. True also means 1, false also means 0. But that's less readable to a human. So to work with Booleans, just include this header file. Alright everybody, so in summary, variables are reusable containers for a value. A variable behaves as if it were the value it contains. Integers store whole numbers that tend to be 4 bytes, at least in modern systems. Floating point numbers are single precision decimal numbers. They take up 4 bytes. A double has double the precision of a float. They use 8 bytes. A char is a single character. They use up 1 byte. Now, an array of characters, also known as a string, you can store words or whole sentences. The size varies, because the strings can vary in length. And then a bool, meaning Boolean, stores either true or false. They use up 1 byte, but they require the standard Boolean header file. We'll have a lot more practice with variables. Now, your assignment is to post an integer, float, char, an array of characters, and a Boolean in the comment section below. That's your homework. And if you don't do your homework, I'm gonna call the police. And well everybody, those are variables in C.